The next quadrilaterals that we're going to focus on are trapezoids and kites. We learned that a trapezoid has one set of parallel sides, and we're going to call that set of parallel sides the bases. And then they have a set of non-parallel sides, which we're going to call the legs. Now in an isosceles trapezoid, we have these legs that are equal, and also the first theorem is going to state that the base angles in this isosceles trapezoid are going to be congruent. So we have these are base angles, this 50 and 50. Okay, and if those are congruent, and we know that they add up to 100, in this whole four-sided figure I should have 360 degrees. So that leaves me with 260 degrees to work with for these other two angles. Now because these lines are parallel, these are acting like transversal. So these are almost like same side interior angles. So this angle would be 130, and this angle would be 130. So those angles would be equal as well. So within this trapezoid, and especially in the isosceles trapezoid, I have two congruent legs, and my base angles are congruent to one another as well. Now the second theorem states that the diagonals of an isosceles trapezoid are congruent. So I have my trapezoid here. It's an isosceles trapezoid, so I need to go ahead and make these markings on the legs to prove that. Now as I draw these diagonal lines from A to C and from B to D, the value of these lines are the exact same. This mainly comes from the fact that they're being divided from these parallel lines and from these congruent angles. Because this angle measurement here, this is 130 and 50, and this is 130 and 50, the distance between these 2 points are the exact same. And that goes into not only the angle measurements, but because of the side lengths. So these diagonal lines are equal to one another, from A to C and from B to D. But again, this is only within isosceles trapezoids. That's the only time it happens. In regular trapezoids that do not have congruent legs, the diagonals are not going to be congruent. The next shape we're going to focus on are kites. Now we know that kites have no sets of parallel sides, and they have two sets of consecutive congruent sides. So if you think of your kite, okay, we know that within our kite here we have two congruent sides at the top that are going to be my shorter sides. And then we have two congruent sides here at the bottom that are going to be longer. So if this side here was 2 inches, then this would be 2 inches. If this was 5 inches, this would be 5 inches. Now the first theorem that we're going to look at states that the diagonals of a kite are perpendicular. So before with my trapezoid it said that the diagonals were equal. Now we're saying that the diagonals of the kite are perpendicular. So they actually when they combine themselves, we're actually looking at 90-degree angles here in the center. Now the other thing that this theorem does not state that is important is that this longer diagonal line is bisecting the shorter diagonal line. So if I said that this length from B to D was 10 units in length, and I'll go ahead and say that this center point where these diagonals connect are E, then this perpendicular line here is also acting as a perpendicular bisector for BD. So I could say that DE and BE would equal 5. If this whole line equaled 10, and this line here is acting as a perpendicular bisector, then it's dividing that 10 into 5 and 5. So that theorem not only should state the diagonals of a kite are perpendicular, but the longer diagonal line acts as a perpendicular bisector with the shorter one. Now the shorter one's not acting as a bisector of the longer one. Okay, it's not, if this AC was 10, I couldn't divide that into 5 and 5. But it's only telling me that this shorter one's being bisected. Now, a couple problems you might see in dealing with this, you can, if we did know this information, that this was 5, and we might even have known that this was 12. If I wanted to figure out what this length was from E to C, I can use this knowledge of the fact that these are perpendicular lines by then being able to use my Pythagorean theorem and find this distance of EC. So you're going to be having to use Pythagorean theorem on a few of these questions to find different lengths, but it all is based on this information of these diagonals are being perpendicular, and also the shorter diagonal is being bisected by the longer. So let's look at a couple of example problems. Example 1. It asked me to find the measures of the numbered angles within the kites. Okay, and this kite here has been given to me with, this is my measurement of angle 1, measurement of angle 2, and 65 degrees. Now, since we know that these diagonals are perpendicular to one another, I can state that inside of this kite, angle 1 would be 90 degrees. Now, if the angle 1 is 90 degrees, then all of these other angles within that 4-angle quadrant here would also be 90. And if this is 65 degrees, then I can state that this angle here would be 25, which means that angle 2 would also be 25 degrees. So I can find any of the measures within this kite if I know, well, obviously I know that these are all 90, but if I just know one more angle measurement, I can figure out some of these angle measurements within this kite. All right, example 2. Example 2 says to find the value of the variable in the isosceles trapezoids. So I have an isosceles trapezoid that's drawn here, and I have an equation for TV and an equation for US. We learned through the theorem that these diagonals are congruent to one another. So I can set the two equations, 2x minus 1 and x plus 2, equal to each other to find the value of the variable. So I go through and cancel out x. I get x minus 1 equals 2. Now I can add 1 to both sides to eliminate 1 and isolate x. So my final value here would be x is equal to 1. So I found the value of my variable. Now in example 3, this is what I want you to do at home, and I'm giving you, this is a shorter note session so that you can have a little bit of time to do this, but you need to be able to graph a kite, or to graph a trapezoid on a coordinate plane. So what I want you to do is I want you to get some graph paper, and I want you to graph a kite. I don't care what your coordinates are as long as it goes and has the same exact characteristics of what a kite should be. Now I've given you a little hint here. When you're drawing this kite, the first thing you should probably do are draw the diagonals. If you can draw those diagonals, since you know that the longer one is a bisector of the shorter one and that they're perpendicular, then if you draw those diagonal lines, you should be able to create the kite on the exterior of those diagonal lines. So a couple things to remember, that the diagonals are perpendicular and that the small diagonal is bisected by the longer one. Now with the isosceles trapezoid, go ahead and draw your pair of parallel sides first. And remember that the base angles are going to be equal to each other. That should help you in plotting an isosceles trapezoid on a graph. Now you should be able to see what the slopes of those sides are with the parallel sides and them being equal. But I want to challenge you to try not to make it to where your kite looked like it did in this example up here. I don't want it to be perfectly vertical. Put some tilt to it. Make it tilted so that this isn't so easy to say, okay, this is perpendicular to this. Challenge yourself. And on the trapezoid, don't make it to where it's, okay, I know that this is a horizontal line, so my slope is 0, so I just want to make another horizontal line. Put some slant to it. Challenge yourself with this. Okay, because that's what you're going to have to be doing on the test to show that you've mastered this material. So again, go through and graph the kite, graph the isosceles trapezoid, just on a coordinate plane, and that's what we will talk about in class on Thursday.